In this lesson we're going to look at how to deal with questions 7, 8 and 9 from the Unit 2 Specimen 2 Higher NAB. So question 7, the diagram consists of two right angled triangles with measurements as shown. We have to find the exact value of sine bracket x minus y. So the first thing you want to do is you want to work out the other sides on the triangle, doing a bit of Pythagoras. Now you can set your working out for Pythagoras. I'm just going to do this in my head because I know that's a 3, 4, 5 triangle. If you wanted to set the working out for Pythagoras, that would be absolutely fine. This triangle here, we should know that root 5 squared is equal to 1 squared plus something else squared. In this case it's going to be 1 squared plus 2 squared. That will give you the 5 to square root here. But again, if you want to do your work in there, that's absolutely fine. The next thing I'm going to do is I'm going to label the triangle. That's hypotenuse, opposite the right angle. This is opposite the angle, and adjacent. Same idea, opposite the angle. This is your hypotenuse, and this is your adjacent. And you get one mark for doing the Pythagoras section here. Not for labeling, but just the Pythagoras section. Now, to find the exact value of sine x minus y, we need to use our addition formula. Now, you will be given them in the assessment. You just need to look at them and pick the correct one. Now, it's sine x cos x cos y, take away cos x sine y. Before we do that, we have to work out sine x and cos x and sine y and cos y from the triangle. So I'm just going to do that just now. I've uncovered one here already. Now sine of x is equal to opposite over hypotenuse from SOHCAHTOA, from trigonometry. So 3 over 5 for sine x. For cos of x, you do the adjacent over hypotenuse, which is 4 over 5. Now turning your attention to the y's, sine of y is equal to opposite over hypotenuse, so it's 2 over root 5. And the cos of y is equal to the adjacent over the hypotenuse from the K bit of SOHCAHTOA, which is 1 over root 5. Okay, we can now expand, as I was saying earlier, expand this out using an addition formula to this sine, cos, cos, sine. The sine stays the same in the middle of take away and take away. It always stays the same with the sine at the front. So now I have this here, I can replace sine x with 3/5. So sine x comes away and the 3/5 goes in. The mistake people make, they put the 3/5 in as x. We're not saying x is 3/5, I'm saying the sine of x is 3/5. And the same with this, cos of x is 4/5, so that goes away. Oh sorry, that's the wrong side there. Cos of y is 1 over root 5, so that goes away and 1 over root 5 comes in. And you're multiplying these two things. So put that in brackets. 3/5 times 1 over root 5. I've not put it in brackets here, but you should put it in brackets. In fact, I'll draw them in badly. There we are. Sorry about that. And the next, put your takeaway in. Put your takeaway in, and then cos of x, look up here, that's 4/5 multiplied by sine of y, 2 over root 5. Again, I'll put some dodgy looking brackets in. There we go. Okay. Right, so now it's a case of multiplying this out. So 3 times 1 is 3, and 5 times root 5 is 5 root 5. And we're taking away 4 times 2 is 8, and 5 times root 5 is 5 root 5. Common denominator now, so I can just do 3 take away 8, which is minus 5 over 5 root 5. And to finish it off, I can cancel these down. So dividing top and bottom by 5, you get negative 1 over root 5. Right, question 8. Show that 3 cos x plus 2 multiplied by 3 cos x minus 2 is equivalent to 5 minus 9 sine squared x. So the way I'm going to do this is I'm going to take this side, the left hand side, and see if I can mess about with that mathematically to try and create this side. So the first thing you want to do here is multiply the brackets. So 3 cos x times 3 cos x is 9 cos x squared, or 9 cos squared x. And then do multiply by the minus 2 and multiply by the plus 2. So you're going to get 2 times 3 is 6, and then you're going to get a minus 6 cos x. And then at the end, 2 times minus 2 is minus 4. So what you should see happening there is that this and this are going to cancel each other out, which just leaves you with this here, 9 cos squared x take away 4. And that's, you get a mark for that. Now, we're not looking for anything involving cos squared x. If I look up at here, I'm trying to make this equivalent to 5 minus 9 sine squared x. I don't really want this bit to be left there. So we have to remember that sine squared x plus cos squared x equals 1, and I can rearrange this at any time to change cos squared x into sine squared x, and to do the opposite, to change sine squared x into something involving cos squared x. So if I replace this here with 1 minus sine squared x, and remember to put it in brackets because it's been multiplied by 9. So 9 times 1 minus sine squared x take away 4, and that gets you the hashtag 2.1 here. And then if I multiply that out, I get this, 9 times 1 is 9, and 9 times sine squared x is 9 sine squared x. And if I do the 9 take away the 4, I get my 5 take away 9 sine squared x, which is what I'm looking for at the top. Okay, last question. Solve 2 cos 2t, take away cos t minus 1 equals 0. We've only to give answers between 0 and 180 degrees. Okay, so we need to use our double angle formula to substitute in here. Now, on the formula sheet, you'll find that cos 2t, this bit here, is equal to 2 cos squared t minus 1. You will also find a substitution with a sign in it, but we don't want that. You want to keep all, once you've substituted in, you want to keep it all as cos's or all as sines. So this is the substitution we want here because of this cos t here. So when we substitute this in, we have to remember that there's a 2 in the front. Okay, so you want to put it in brackets and put the 2 in front of the brackets. So that's gone into here with the 2 multiplier. So take away cos t, take away 1 equals 0. Multiply the brackets, so you're going to get a 4 there, and then a minus 2. So 4 cos squared t minus 2, and then the rest stays the same. I'm then going to keep the squares at the front, put the cos t in the middle, and I'm going to take away the 2 and the negative 1 to get minus 3. So I'm going to leave it like that. At this point, what you're looking to do is factorise. So you want to factorise this into double brackets. Now some people find it easier to think of this as that 4, in fact, I'll type it, 4x squared minus x minus 3. Change that. So people tend to find that easier to do. So that goes into double brackets just like this. The only difference is they've put a cos here. I suppose we could change that to t to make it even more the same. So if I'm going into double brackets, the first thing I need to look at is this 3 at the end. I know that the bracket is going to need a 3 at the end and a 1 at the end. So it's going to have to have that to create the negative 3. Okay, so on here you can do the same thing. We can have a 3 at the end, and we'll also see if we can get this right. I didn't, and a 1 here, and you're starting your brackets there. Now we have to consider this negative 1 in the middle. So to get a negative 1, you can either have the 4 here and the 1 cos t. You could have a 2 cos t and a 2 cos t to make the 4 cos t squared. A 2 and a 2 are going to give you a 6 and a 2 there. So that's not really going to work. If I put a 2 here and a 2 here, that's going to give me a 2 and a 6. So that's not going to make the negative 2 in the middle. So I'm not going to use a 2 and a 2. If I use a 4 and a 1 like this, then I'm going to generate a 1 and a 12. That doesn't really help me get there, so it must be the other way around. It must be a 1 and a 4. And that's going to generate a 4 and a 3. Now I can work with that, a 4 and a 3. Now I'm looking for negative 1. So it's got to be negative 3 and, a negative 4 and a plus 3. So negative 4, it's got to be negative here, and a plus 3 here. So I'll just replace the t's, if you like, with cos t. Okay, so either that bit's going to be equal to 0 or that bit's going to be equal to 0. So I'll set that up like this. And if we can solve these two things, we're going to get the right answers. So cos t equals 1. So the answer to that, if you inverse cos and think where the cosine wave is 1, it's going to be 0 or 360. But if we look at up here, we're not interested in 360, so we'll just put 0. In this one, take away the 3 and divide by 4. So we'll take away the 3, divide by 4. Now, to work out the values of t here, you have to inverse cos 3/4 to get your acute angle. And that's going to give me 41.4. And then I have to tick what quadrants that this is in. So cos is negative, so that's going to be there and here. So the answer you're looking for is really 180 take away 41.4, which is going to give me 138.6. And 180 plus 41.4 is actually going to give me 200 and something, which I'm not interested in. I'm only interested in answers between 0 and 180. So there's my two answers. So this gives you a mark here, and these two answers give you a mark here.